So on Monday, apparently, we started this, and I feel like you guys picked up on this pretty easy. It's not hard. It's not difficult at all. I'm going to show you two different variations of these type of problems. But again, it's like I told first period. Chemistry is not hard as long as you, and I know some of you rolling your eyes, as long as you follow the process. You can change any formula, any compound, any number, but the process never changes. Okay, just like with oxidation numbers, I can give you any formula, but if you ask yourself the exact same questions, you'll never miss one. Just like naming a compound. As you notice, every time we did one, I asked myself the exact same questions, and as long as you can follow that process, this is not too terribly hard. So what we're going to do is we're going to do molar mass, and now the new thing that you did not learn the first time we did this was percent by mass. And so again, let's follow the procedure. So the first thing you're going to do is write down the elements that are present. So, I know. What are the 4 elements that are present? Magnesium, carbon, hydrogen, and oxygen. Okay? It is MgC2H3O2, all in parentheses with a 2 out behind it. Okay? All right, Blaze, how many magnesiums are present? Say that again? No, I didn't hear you. 1. Okay? Ryan, be very careful. How many carbons are present? 4. How did you get 4? Very good. Okay? Anijah, how many hydrogens? 6. Very good. And then Jesus, how many oxygens? 4. Very good. So that's the first thing you got to do. Everybody in this room can do that. That is not a challenge. But if you do not distribute, it's going to mess you up. Okay. The next thing we're going to do is we're going to multiply each element by what value? The mass. Now let me ask you this. Everyone should know this by this point. How many decimal places do you always round to? 2. If you have a calculator as well, you probably want to get it out at this point. Romy, what's magnesium? $24.31. All right. Emma, what's carbon? Brennan, what's hydrogen? Point. Okay, Ryan, oxygen. 16, very good. Now from this point, you did not have to know anything about chemistry to be able to do that. You could get your 6-year-old brother to do that if you have one. All they have to do is find the letter and write down the number. Now the next part, all you have to do is a little bit of math. Let your calculator do the work for you. 24.31 times 1, that's probably the easiest part on here. What is 4 times 12.01? 48.04. What is 6 times 1.01? 6.06. And then finally, 4 times 16. 64. Very good. Now, that's each part. That's how much magnesium's mass is for total. That's how much total carbon you have, how much total hydrogen you have, and how much total oxygen you have. Now, how do I find the total mass of the entire thing? Add them all up. Has anybody got a number for me? See, that's going to be 11. That's going to be 4, 10, 12, so 2, 20, something. Thank you, 142.41. Now, on the test, if you write that, would you earn full credit? No, what's missing? The unit, which is gram per mole. Do you all agree this is pretty simple? It's not. Now, that's the mass. We're going to do one extra step, and this is just as easy. It's all calculator based. On Monday, I asked you, what is the most basic definition of a percent you could possibly give me? Part over whole. How many parts are there in this thing? 4 parts. What's your whole? 142. So we're going to divide all 4 parts by the entire whole. So 142.41 divided by each part. Now, if you divide it in your calculator and you come up with a decimal, what's wrong with that? Multiply it times 100, or what's even easier than that? Just move the decimal 2 places to the right and get me a whole number. Okay? Now, let me give you two ways to double check your final answer. The first way is just using your eyeballs. Which part should have the lowest percentage? Don't give me the exact element. Tell me how you would know just looking. The lowest number should have the lowest percentage. What is the lowest number? Hydrogen. So when you do this, hydrogen should have the lowest percentage. Which element should have the highest percentage? Oxygen has the highest number. That's looking at it eyeball to eyeball. How could you actually do one more calculation to double check, make sure your answer is right? What do all percentages add up to? 100. Now, I told you this Monday, and this should be a good thing for you. Do you have to always, every single time, get exactly 100? Now, remember what I told you? You can get 99 or 101 and you're still okay. I'm not going to mark it wrong. That's perfectly fine. Again, that's because of rounding issues. All right, so what is the percentage of magnesium? Okay, 17%. What about carbon? 33%. What about hydrogen? 4%. And then finally, oxygen is 45%. Okay? What I did is I took each purple number, Anijah, each purple number, and divided it by the red number. So 24.31 divided by 142.41 gave me 0.17. Remember what I told you had to do? Move the decimal 2 places to the right. Gage? Just always round percentages to whole numbers. Okay? For us, now, Gage, you can have a decimal point percentage, but never in this. Okay? Now, let me ask you something. What is 17, or what is 7 plus 3? 10. What is 4 plus 5? 9. So do you agree that's 99%? Okay. Would that be okay? Absolutely it would be. I'm perfectly fine with that. There is somewhere in here a number that wasn't rounded correctly, but that's okay. Or it may have been over-rounded or under-rounded, but that's fine. As long as it's within 99 to 101, we're good. That is, all of those purple numbers are the percents of each element in the entire compound. No, ma'am. Well, the 99 is you add them all up. All I want are these numbers. 99 is just a double check. Does that make sense? That's as hard as it gets. Okay? It's as hard as it gets. Now, and I think I said this on Monday, which I don't think you were here, Bailey. So if I asked you this question, I said, Bailey, tell me what percentage of the population in this room is made up of girls. How would you do it? Exactly. Part by whole, right? Part girls, whole is the total number. But you wouldn't give me the fraction or the decimal. You would give me the percentage. So really what you would have is the percentage value, not the decimal value, right? Okay. Now, let's look at one more thing. Mr. Meggs. All right. Does this one look a little bit weirder? Yes, if you're writing this on your own paper, yes, that is a dot, and yes, those are 5 waters. Here's what I want you to write behind this thing. This is called, oops, that's not what I wanted. This thing is called, so somebody said it? This thing is called a hydrate. It is CuSO4. And there's a really big bold dot and then 5 waters. Now, what does hydro mean? Water. When someone says hydrate yourself, what does that mean? Drink water. So let me tell you molecularly what's going on here. I'm actually going to kind of step away from this for just a second. So in this compound, how many waters are there? 5. So let's pretend for just a second that water. So I'm going to take these 5 Chris's are your edits. So pretend that I am CuSO4. And what I have just done is I have hydrated myself again. It's hydrating water. So I now have 5 waters that are surrounding me. Now, why is this important? Is because sometimes compounds are more stable ask you something. If I told you that I wanted you to get rid of all of these waters from around that copper 2 sulfate, how would you get rid of them? Evaporate them. How do you evaporate something? Heat it up. Now here's the problem. When you begin heating something up, how do you know that the copper sulfate's not leaving and the water's leaving? Say that one more time. It's boiling point. What does boiling point mean? And do not say the point at which it boils. It's the temperature at which boiling occurs. Okay? Now, there's a big difference. A point is a little dot. A temperature is a value. There's a huge difference. Now, so that's experimentally. So what you would literally do is you would boil it, you would weigh it, and you would calculate the difference. It's not any fun. Now, for some of you that don't like this word, there's another word that you will sometimes see or hear me refer to it as. A dot water. If I said that is, or write me, or recognize the dot water, is it obvious that's a dot water? How do you know? There's a dot and a water. All right, so let's figure out what the the molar mass of this compound is, and then the percent composition. So there's just one small little additional step that we have to do, but it's very easy. So the first thing we're going to do is list the elements that are present. Now, for right now, completely ignore the water. Act like it's not even there. So how many elements are in the first part? 3. All right, so I've got Cu, I've got S, and I've got O. Cu, S, and O. Okay, Jamila, how many coppers are present? 1. Jalen, how many sulfurs are present? And Tristan, how many oxygens? 4. All right, this time, Lily, what am I multiplying it by? The mass. Bailey, what is the mass of copper? Very good. Brett, what is the mass of sulfur? Very good. And Marquise, the mass of oxygen? 16. Again, no thinking, just using your eyeballs, looking and writing it down. The next part, just let your calculator do the work for you. Multiply it all out. So I've got 63.55. I've got 32.06. And then I've got 64.00. All right, so I've got 11. I've got 6. 5. So I've got 9, 12. Plus 3 is 159.61. Now, again, would you receive full credit for that answer? No. What you got to put? Yes, ma'am. Grams over moles. Now, here's the problem with this one that was different from the last one. What have we not accounted for yet? The water. Here's what you do, and it's very easy. Very easy. First question is, how many waters are there? 5 of them. Write down 5, and then write an open parenthesis. We're going to put something behind that parenthesis. When we first started this class, I asked you guys, have you written any of this down yet? This is a daily issue. Write it down. I asked you, the very beginning of this year, to memorize 1 molar mass. And that 1 molar mass I asked you to memorize was water. Does anyone remember what it was? It's the only one I asked you to memorize. No. 18 point what? 18.02. So let me say it again. I'm asking you to memorize 1 mass out of the billions of molecules on the face of this planet. That's the only one I'm asking you to memorize is water. 18.02. Now this next part, again, is pure calculator, but it scares me to death because some of your skills in math are subpar. What is the first thing you would do to calculate the new mass? Multiply first. So you'll multiply 5 times 18.02 and then do what? Add it. Now, the first thing I need you to do, and this is important, is water technically a part of this compound? Yes. So how many parts did we start with? 3. But water is our 4th part. So someone please tell me that number. What is 5 times 18.02? Alright, so I'm going to write this right here. So 90.10, and then tell me what the total mass is. 249.7 what? 71 grams per mole. So the only difference between this problem and the last one is what do we have to account for? 5 waters. And all you have to do is multiply 5 times 18.02 and add it to the bottom of it. Now, everything else stays the same. So again, my question to you is, what does percent mean? Part over whole. How many parts did we have? We had 4. This is a part. This is a part. And you don't have to circle these if you don't want to. That is a part. And that is a part. 4 parts. What's the whole? Okay. 249.71. And just like I asked you last question, with your eyes, can you tell me which part should be the lowest percentage? Who is it? Who's the lowest number? Sulfur. Sulfur's 32, oxygen 64. Very good question. You've got to look at those. Okay, you got to look at the ones in the circles. Now, just with your eyes, can you tell me which one should have the highest percentage? Water should have the highest percentage. Water should have the highest percentage. All right. So will someone please tell me what the percent of copper is? 26%. Will somebody tell me what sulfur is? 13%. What about oxygen? Huh? That's right. That kind of confused me for a second. And then the last one. 33 or 36? 36. You would do 63.55 divided by 249.71. Okay? All right, what is 6 plus 6? 12. What is 6 plus 3? 9. What is 9 plus 12? 21. So that means it's 101. One. So plus or minus 1 on either side of 100. So again, this is a little bit, something is a little off with your rounding, but that's okay. As long as you're within the 101 or 99, I'm totally fine with it. All right. You guys try A, and just to double check and make sure that you can actually do this. I'm going to leave this up so you can reference back to it, but you guys do the next one. MgSO4.7H2O. This is what I got so far. I got the mass of the ionic part to be 120.37. I do need your help from this point on. What is the mass of the 7 waters? 126 point what? 14? I hear a bunch of different numbers. All right, and so what's my total mass now? Brian Dismukes, give it to me. 0.51 gram per mole. All right, now, and again, I now need to divide by my whole, which is 246.51, and that's going to give me my final percentages. All right, what was the percent for magnesium? 10. All right, what about sulfur? 13. What about oxygen? 26. And finally, what about water? 51%. All right, what is 0 plus 3? 3. And what is 6 plus 1? 7. What's 7 plus 3? 10. So that's got to be 100%. Yep, doesn't matter. I do that weird. But here's why. I know what the last value is. I know what the first two values are. If it's a 0, it's 100. If it's 9, it's 99. If it's a 1, it's 101. I don't have to do the other part of it. I know what the first two numbers are. I'm just making it easier for myself. Yes, ma'am. All right, that's a good question. The way that this question will be worded on the test is, what is the percent of each element in the compound? So you would say Mg is 10, S is 13, O is 26, and water is 51. Those would be your four answers. Yeah. But so since you got 99 because you had 25 versus 26. And that's why I give you that one way either way. Okay? Everybody good on this? Now, I want to do one more with you guys because I'm fixing to show you a compound that is ridiculous in terms of its mass. Okay? So let's work B. This is H. Matter of fact, I'm going to come off this page. It is Hg. Hg. Did it wrong. Hg2 3 PO4 2. Now, there's lots of numbers, but how many parts are there? How many parts are there? There are 3 parts. What's your 3 parts? Hg, P, and O. I don't ever finish this out. Lauren, how many mercuries are there? 6. Very good. Sharon, how many phosphoruses? 2. Very good. And Massimo, how many oxygens? 8. And this is where you're going to start seeing big numbers. What is the mass of 1 mercury? Is it 200 even? 200 even, 0.59. And how many of those do we have? 6. So that's going to be at least what number? At least 1,200. Right? At least 1,200. So we're going to have a huge mass here. All right, now, phosphorus. I can never remember phosphorus. Somebody help me out. 30.97 though, right? But I say when you said that, I was like, that's... And then oxygen is, of course, always 16. So this is where, again, don't overcomplicate it, so let your calculator work for you. What is 6 times 200.59? It's 1,200 something. Thank you, sir. And then 2 times 30.97 is going to be 61 something. And then 8 times 16. 240? Why did I say that? 124. Okay? Now, we're going to have a huge mass here. So, even though the numbers are... What's wrong? It's 128. Duh, that was stupid. Even though the numbers are super, super huge, the answer in the process still isn't going to change. It's the exact same thing. You just got much bigger numbers to deal with. First couple of numbers. Remember, always 2 decimal places. That's a rule. Always 2 decimal places. So I know it's 4. I know it's another 4. Sir? Wow, how did I get 4 right there? I guess I missed that top 4. All right, 1,000 what? 390? 393. All right, so 1,393.48. And again, would you receive full credit for that? No. Make sure you get the grams per mole in there. I'm telling you right now, somebody on the test is going to get that written on there because they're not paying attention. And they're going to lose 1 point per question if you don't put that. That's 1 point per question. Simply writing gram per mole. don't be the fool that loses points. Now, let's use your eyeballs again. Based on the numbers alone, what is obviously going to be the highest percentage of this thing? Definitely going to be mercury by a large margin. A large margin. Okay, so I've got 1393.48. Does anyone have the percentage yet? Should be 80 something. 86. 86%. Oxygen's like 4, isn't it? And then the next one, 20. No, 10. 10%. And that adds up to be 100%. So again, really big numbers. Nothing more nothing is more. It doesn't get any more complicated, even though the numbers get bigger. We've got to do one more little small thing, and it's a review of stuff we've done before. So it's nothing new. We will test on oxidation numbers. These two things. These are technically two things, and then the small thing we're going to start tomorrow. And we'll probably test on that either Monday or Tuesday, depending on how the rest of the week goes. Be words? Yes, some of them will be, yes. Okay. All right. The last little thing that I want to go back, and this is just something that I want to increase your knowledge, and it's how to name a dot water. The first thing I want to quiz you on, and you've already done these, so if you've got some spare room, I want you to just name the two things that are boxed in green. And we'll come back and we'll worry about the dot water in a second. But just name those two things. Just like if this were a test, just those two. See if you can name them. Alright, so let's do the bottom one first because it's much, much easier. So my first question is, what is Mg? Magnesium. Look at you. Now, there's a reason why I wanted to write this down, and this is the reason why I started with this one, is because magnesium is a metal, but what kind of metal is it not? It's not a transition, so what do I not need in the name? Don't need a Roman numeral nor a prefix. And Anijah, what is SO4? Sulfate. Now, I want to go back up and I just want to go ahead and do the copper one, and I'll come back and I will add the dot water part to it. The dot water is super simple. But let's go back up and let's look at the top one. Now, first of all, what is Cu? Copper. What kind of metal is it? It is a transition. So I've got to have something in there, but I do know that it's copper something sulfate. So I'm going to go ahead and write sulfate. But here's the deal. I've got to figure out what that Roman numeral is. Does the 4 belong to the copper? No. Who does the 4 in CuSO4 belong to? It belongs to sulfate. You cannot steal it. So we drop the parentheses for a reason. When and only when can you drop the parentheses? When there's a 1 behind it. But here's the deal. If you pull back a 1 plus 1 minus 1, is that right or is that wrong? That is where you guys, as a general consensus, don't know this answer because you don't know your polyatomics. Is that right for sulfate? No. What is sulfate supposed to be? 2 negative. Well, if you change that to a 2 negative, change that to a 2 positive, now it is correct. How many of you got copper 2? 1. Be honest. I need to know. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, it's a consistent issue. Yes, ma'am. I've told y'all that naming compounds is not going away. Yeah, we need to do polyatomics again. Now, last thing. Guys, give me 2 more minutes and we're done. We need to account for what, Massimo? What have we not accounted for in either name yet? The water. We've got to account for the water. Let me tell you how easy this is. Here's my first question. Massimo, What is the prefix for the number 5? All right, everyone, write down the word penta. Now, Brennan, this whole compound, the very first word that you wrote down when we first started talking about this was what word? It started with an H. That whole thing, that compound, is called a hydrate. So all you have to do is write the prefix and write the word hydrate. No, hold that question. Hold that question. So, if you ever see a dot water, you literally name the compound as normal and then add the prefix of the amount of waters and then add the word hydrate. So, since Anijah asked that question, write down the final part of the second one. Do not say out loud what 7 is. I want to see how many of you know what it is. Do not say it out loud. Please don't say it out loud. Yes, not all one word, but it's all one compound. How many of you wrote hepta? Very good. All right. What? So magnesium sulfate heptahydrate is the final answer. Hang on. I want you to try to do one last. We have 6 minutes left, so I want you to do one more. Yes, please write the name. Guys, please, as soon as you do these, we're done. As soon as you do these, write them down. The one in the black, write the name. The one in the blue, write the formula. Yeah, the one in the black, write the name. The one in the blue, write the formula. These are 2 different problems. Well, if you're watching, there is your answer. Iron, Roman numeral 3 chloride. Hexa comes from 6 hydrate. Barium chloride, barium's in group 2. Chlorine's in group 17, so -1. So BaCl2.2 waters because of dihydrate.